Okay, so this section is all about multiplying and dividing exponents. The vocabulary that you need is these 3 words. This word monomial, it's like a term almost. It says a number, a variable, or the product of numbers and variables. So we're going to write some examples beside this. So it can be literally any number, positive or negative, like 3, or it can be negative 20, anything like that. Or it could just be a variable, so like x, or a product of numbers and variables, like 2x, or even 3y squared z. Okay, any of those are examples of monomials. Okay, so then a constant is a monomial that is a real number. So basically just like these first 2 examples, I showed you 3 and negative 20. That's an example of a constant. And then a power is any term with an exponent. So something like the last one, 3y squared z. And really, you could count these 2 as powers too. Because what exponent does that have? A 1, and so does this one. Okay, so determine whether each expression is a monomial. This can get kind of tricky. So remember, a monomial, it only has multiplication. It doesn't have addition or subtraction or division. Okay, only multiplication. So this first one, negative x plus 5, we say no, and it's because there's addition. This is actually 2 monomials being added together. We're going to get into this later, but if you have 2 monomials being added together, it's called a binomial. And then a 3 would be a trinomial. And then after that, you just say polynomial. Okay, so this next one, yes, this is because it's only multiplication. C and E, pay attention to these. C is yes. You notice you have a constant in the denominator. This is okay. The reason this is okay is because I could rewrite it this way. This one is not okay. I can't divide by a variable. Anytime you divide by a variable, it's not a monomial. This one's really important. I would highlight this one. Okay, and then D, it is a monomial because it's just a constant. All constants are monomials. Okay, so on your own, try to look at these and say yes or no. You don't have to explain. Oh, actually you do. I take that back. If it's no, explain. If it's yes, you don't have to. Okay, so F, this one should be no. Remember what this one's called? There's 2 monomials. A binomial. Okay, so we can say no. It has subtraction. The next one, this one is yes. But it is a product. It only has multiplication. Okay. And then H is also yes, because this is just a constant. And then this last one is no. This is the one that people miss if they're going to miss one. And we say no because there is division by a variable. So the next part we actually get into multiplying monomials. I'm going to show you how this works, but you've probably seen this before. If you have b to the third power, that's like saying b times b times b. And if you have b to the fifth power, that's like saying b times b times b times b times b. We have 3 b's, 5 b's. So you end up with b to the 8th. So the shortcut, instead of actually having to write that out every time, is just to add the exponents, and you get the last one. Now, this first example right here, this one's a little different because there's coefficients in front of it. Remember that adding only applies to the exponents. The coefficients you multiply like normal. So the coefficients 3 and 7, I would multiply those and get 21. And then the two exponents I add, 4 plus 5 is 9. So if you want to write a little note right here, you can say multiply the coefficients and add the exponents. Okay, so the next one, here's one that you can practice. Just before you do this, remember that if you do not see an exponent, there's a 1 right there. So this is r to the first and t to the first. And then also remember, we can only add the exponents if they have the same base. So like you add the r's together, you add the x's together, and then you add the t's together. And then the coefficients you multiply. Okay, so everybody try that. Okay, so you should get 24 when you multiply -4 and -6, and then r to the 6th power, x to the 4th, and then t to the 4th. And that's your answer. Okay, so the next rule is power to power. So when you have a power to a power, you multiply the exponents. I'm going to show you how this works, but with smaller numbers. This is like if you have b to the 2nd raised to the 3rd power. So what that means is you're going to do b squared times itself 3 times, like this. So then you could break this down even further. You do b You could do b times b 3 times. So you end up with b to the 6th. So of course you don't have to do that every time. You can just use the trick and multiply 2 times 3 and get 6. I just think it's good to know where it comes from. So on this example, it's the same exact thing. It's just a power raised to a power and then another one. You can just multiply all 3 of these numbers. So you do 2 times 2 times 4 and get 16. So remember, in this, we're simplifying. It doesn't say solve. Okay, it just says simplify. So that just means write it in simpler terms with exponents. Don't actually figure out what is 2 to the 16th power. Okay, you'll try this one. Okay, so on this one, we're multiplying 3 times 3 times 2. So you should get 2 to the 18th power. Okay, and this next part is definitely the most confusing part of all of it. And we're actually going to add another example to our notes to make sure that you understand this. But the reason that this is confusing is because it's almost like you have to use the distributive property, but with exponents. I've got to distribute this 5 exponent to the y, to the x, and to this negative 2. What people always mess up on is they want to do negative 2 times 5 and say that's negative 10. But negative 2 is obviously not an exponent, that's a coefficient. So I have to do negative 2 to the 5th power, and then x to the 5th, and then y to the 10th. Okay, so add an extra example to this. We're going to add negative 3 x to the 3rd y squared z, all raised to the 3rd power. So I personally like to write this out another time when I'm doing this, because I like to show that I'm going to do this coefficient to the 3rd power. So it's going to be negative 3 to the 3rd power, and then I'm going to have x cubed to the 3rd power, and then y squared to the 3rd power, and then z to the 3rd power. I'll need everybody to be really careful when you do a negative base with an exponent, because if you were to put this in your calculator, you have to put parentheses around the negative 3, or it's not going to realize that you want that to be the whole base to be negative. So negative 3 to the 3rd power is negative 27, and then we multiply all these exponents. So I have x to the 9th, y to the 6th, z to the 3rd. And that's my answer. Okay, so the last ones we're going to do today, they have to do with area, and some that we'll have to do later have to do with volume. That means you need to know these basic formulas. I'm not going to give you any of them on your test. This first one is just area of a square, so we should all know that is, you can either use length times width, or you can use the side length squared. And the next one we're going to do is area of a triangle. So for that one, you can either think of it as area equals 1/2 base times height, or you can think of it as area equals base times height divided by 2. Whichever you prefer is fine. So in the one that's already worked out for you, we use the formula side length squared. So the side length is 3xy squared. So all of that to the 2nd power. So just like before, we distributed this exponent to everything. The 3 squared, x squared, and then y squared times 2, so y to the 4th. You get 9x squared y to the 4th. Okay, try to do this next one. You can use either formula you want. I probably like the first formula better. But whatever you want is okay. Okay, so I like to take care of these second two terms first. So I multiply the 5 and the 4. So I have 1/2 times 20. And then remember, with these exponents I add. So I have, that looks like an exponent right there, it's not. I have a to the 2nd, b to the 2nd, And then I multiply by 1/2. So remember, you're only multiplying the coefficient. This doesn't have anything to do with the exponents. So it's a equals 20 a squared b squared.